Hey guys, just recording some solutions to assignment 1. Okay, for the first question, we're given 3 sets, and we have to construct a set D such that the elements of D are exactly A, B, C. Okay. So first let's just construct the ordered pair of A and B. So this is a set by axiom of pairing. This is also a set by axiom of pairing. Okay. Now I have 2 sets, so I can use the axiom of pairing again. Okay. And now I can use the axiom of unions. Okay, so let D be the union of this. Okay. By axiom of unions. Now, the definition of the union says that X is in D if and only if X is in AB or X is in C. And if we unravel that a little bit, that's true if and only if. Well, the elements of, like, the axiom of pairing says that X is in this set if and only if X equals A or X equals B. And then this means that X equals C. Okay, so this is our set we want. The end. Okay, let's move on to question 4. As I may have mentioned, this is just like Russell's paradox in disguise. Okay, so by axiom schema of comprehension, you can construct a set B to be the elements of A which are not elements of themselves. Okay, this is our property. Our set is A, and we get this set B. Okay, this is fine. So let's show that B is not in A. So now we claim B is not in A. If B is in A, well, that we do the usual Russell's paradox thing. Either B is not in B, or B is in B. Okay. If B is not in A, one of these two things is fine. Doesn't lead to a contradiction. Okay. But if B is in A, and let's see what happens if B is in A and this happens. Okay, I mean, this is just the usual thing, but let's go through it anyways. So if case B is not in B, then B is in A and this property holds, and that means that B is in B. So B is an element of this set. and that set is just called B, so B is in B. Well, that's a contradiction. Okay, the other case is that B is an element of B. Okay, so B is an element of B, and B is all the things in A such that the thing isn't an element of itself. So it satisfies this property. Well, that means that B is not an element of B. Again, that's a contradiction. Both cases lead to a contradiction. Well, that means that our assumption that B is in A is impossible, so B is not in A. And we are done. Okay, let's move on to question 5. Okay. So first, the idea is we have to first construct the unordered pair, and then take the union. Okay. This is a set by axiom of pairing. Okay. Now let's say that C, which is a union of A and B, is a set by axiom of union. Okay, now X is in C if and only if X is in, let's say, I need another letter. X is in D for some D in this unordered pair. So the possibilities for D are just A or B. So we can write this as X is in A or X is in B. Okay. And the X's that are in A or B, that's exactly the union. So C must be the X's such that X is in A or X is in B. And C is a set by our two axioms, so we are done. Thank you for watching this video.